Your brain, upgraded, wished you could download a new skill in seconds? Or control technology just by thinking about it? That's the future Elon Musk is building with Neuralink. This visionary entrepreneur, known for pushing the limits of what's possible, is now taking on the ultimate challenge, merging your mind with machines. From electric vehicles with Tesla to space exploration with SpaceX, he has now turned his gaze towards the final frontier, our minds. But what prompted this shift? Musk's concern about the unchecked growth of artificial intelligence. He believes that Neuralink, a brain-machine interface, could be our safeguard against a potential AI takeover. Unexpectedly launched, Neuralink has the potential to revolutionize how we interact with technology, amplifying our cognitive abilities, and opening new avenues of communication. So, has Elon Musk opened the door to a new era of human potential? Let's subscribe, like the video, and delve deeper. We stand on the precipice of a future where humans and machines might not just coexist but merge. This is what futurists call the singularity, a hypothetical point where technological growth becomes uncontrollable and irreversible, resulting in unfathomable changes to human civilization. At the heart of this concept is the fusion of our biological intelligence with artificial intelligence. Imagine a world where our minds are seamlessly integrated with machines, augmenting our cognitive abilities beyond the natural limits. This isn't science fiction. It's the very real future that Elon Musk's Neuralink is striving to build. Neuralink's vision is to create a high-bandwidth implantable brain-machine interface, a conduit to connect us directly to the digital world. It's a bold step, a potential stepping stone towards the singularity, blurring the line between human and machine like never before. But how does Neuralink aim to achieve this? Time to understand the science beneath the surface. To understand Neuralink, we first need to understand brain-machine interfaces, or BMIs. At their core, BMIs are a bridge between the human brain and external devices. They can read the symphony of electrical impulses in our brains, translate them into meaningful commands, and send these commands to a machine. This process allows for a direct line of communication between the brain and the machine, bypassing the need for physical action. The brain is an intricate network of about 100 billion neurons, each communicating through electrical signals. BMIs function by detecting and interpreting these signals. Imagine your brain as an orchestra, and the BMI as a conductor, interpreting the symphony and guiding the musicians, or in this case, machines. However, the interpretation of these signals is no small feat. Our brains are not simple binary systems, but complex, dynamic networks. The sheer volume and speed of data generated by our brains present a significant challenge. Previous BMIs have grappled with this, often limited by slow data transmission and a lack of precision. Another limitation of past BMIs is the invasiveness of the technology. Traditional BMIs often require surgical procedures to implant electrodes into the brain. This process carries potential risks and complications, making it inaccessible for many. But imagine a BMI that could overcome these limitations. A device that could process brain signals with unprecedented speed and precision and perhaps even be non-invasive. This is the promise of Neuralink. It aims to revolutionize the field of BMIs, opening up a world of possibilities from restoring lost function to controlling the world with your mind. With an understanding of BMIs, we can now explore the inner workings of Neuralink. Neuralink isn't just a concept, it's a complex piece of technology. At the heart of Neuralink's cutting-edge science is the implant, a tiny device that burrows into the brain. It's made up of hundreds of electrodes, each thinner than a strand of human hair. These electrodes are threaded into the brain's outer layer, the cortex, where they listen in on the electrical chatter of neurons. Each neuron's electrical signal is a message, and Neuralink is the interpreter, translating these signals into a language that machines can understand. But how do these delicate threads find their way into the brain? That's where the robot surgeon comes into play. This isn't your typical operating room giant. It's a finely tuned machine capable of navigating the brain's intricate landscape with micron precision. It carefully inserts the threads, avoiding blood vessels and minimizing damage to the brain. It's a delicate dance, a blend of human oversight and robotic precision. Once implanted, the Neuralink device doesn't just sit idly. It's hard at work, processing and interpreting neural signals. The data processing chip, the brain of the implant if you will, takes these signals and transforms them into commands. Imagine a thought turned into a text message, or a memory saved like a video file. That's the power of Neuralink. As for powering this tiny marvel, it's wirelessly charged, eliminating the need for any external wires. This not only makes it more comfortable for the user, but also reduces the risk of infection. It's a careful balance of power and safety, a testament to the ingenuity behind Neuralink. So there you have it, a peek into the technology that drives Neuralink. From the microscopic electrodes to the data processing chip and the robot-assisted surgery that brings it all together. It's clear that Neuralink is more than just a dream, but what can it do in practical terms? Neuralink isn't just about merging humans and machines, it's about healing and hope. Picture this. Brain-machine interfaces, or BMIs, are not a new concept. They've been used in medical applications for years. Take deep brain stimulation, a treatment for Parkinson's disease, where electrical impulses are sent to specific parts of the brain. The technology is life-changing, but it's also limited, offering only a crude level of control. Now, imagine a future where Neuralink's advanced BMI could offer a solution. Picture a world where those with sensory or motor function limitations due to spinal injuries, neurological conditions, or amputations could regain control. Imagine being able to see, hear, or walk again, not through a miracle, but through the innovation of Neuralink. This isn't science fiction, it's a future that Neuralink is striving to make a reality. By translating brain signals into commands, Neuralink could potentially restore lost function, giving individuals a newfound independence and quality of life. Neuralink's potential medical applications are exciting, but they're just the beginning. Imagine controlling devices with your mind. Neuralink could make this a reality. This revolutionary technology aims to transform the way we interact with the world, taking us beyond the limitations of our bodies. Imagine a future where advanced prosthetics are not just appendages but extensions of your thoughts, responding to your intentions in real time. The beauty of Neuralink lies in its potential for such seamless integration. But it doesn't stop at prosthetics. Picture a world where we can operate machines, navigate digital spaces, and even command our own smart homes, all with the power of thought. But what if we could achieve all this without invasive surgery? The future could hold non-invasive brain-machine interfaces, or BMIs, that sit on the surface of the brain, interpreting your mental commands without the need for implants. Neuralink opens up a world of possibilities, but it also raises important ethical questions. As we move towards a future where our brains interface with machines, we must ask, are we ready for the ethical challenges? Neuralink, Elon Musk's revolutionary venture, is at the forefront of these concerns. It promises to unlock unparalleled opportunities for human augmentation, but it also raises significant ethical questions. For instance, how do we ensure privacy when our thoughts could potentially be read by a machine? What measures are in place to protect against hacking or misuse of personal neural data? And as this technology advances, what stops it from being used for nefarious purposes such as mind control or forced behavior modification? Moreover, as we venture into the realm of human augmentation, we must consider its societal implications. If only the wealthy can afford Neuralink, will it create an even wider gap between the rich and the poor? Will those with neural implants be considered superior, leading to a new form of discrimination? The ethical implications of Neuralink are vast and complex, but what does this mean for the future of humanity? Neuralink could be a stepping stone towards the singularity, a future where humans and machines merge. This revolutionary technology is not merely about curing diseases or augmenting abilities. It's about fundamentally redefining what it means to be human. The concept of the singularity is profound, envisioning a future where we transcend our biological limitations. Neuralink could be a key player in this transformative journey, bridging the gap between our organic minds and the realm of artificial intelligence. This is where transhumanism comes into play. Transhumanism is a movement that advocates for the use of technology to enhance the human condition, pushing the boundaries of our capabilities. With Neuralink, we might not just interact with machines, we could become part machine ourselves. Imagine having the ability to download knowledge, to communicate telepathically, or to control devices with just a thought. This is not science fiction, this is a potential reality with Neuralink. However, as with all revolutionary ideas, Neuralink comes with its share of challenges. The technical hurdles are immense, and the ethical implications are even more profound. How do we ensure privacy when our thoughts could be read by machines? How do we prevent misuse of such a powerful technology? The future of Neuralink is full of potential but also challenges. As we stand on the brink of a new era, it's clear that our journey towards the singularity is just beginning. Beyond healing, Neuralink could open up a world of possibilities that we can only begin to imagine. Picture this: a world where language barriers crumble as we communicate directly, brain to brain, each understanding the other's thoughts and emotions, in real time. A world where our memories are not limited by the confines of our biological brain, but enhanced and stored in a digital cloud, accessible at any moment. Imagine entertainment that is not just seen or heard, but fully experienced, with virtual realities indistinguishable from our own. Neuralink could turn these dreams into realities, transforming the way we interact with the world and with each other. But the most intriguing prospect may be the concept of brain-to-brain communication. Imagine sharing thoughts, feelings, even dreams directly with another person's mind. A telepathic world once the stuff of science fiction could be within our reach. The possibilities are endless, but so are the challenges. Like any pioneering technology, Neuralink faces its share of challenges. From a technical perspective, there's the daunting task of ensuring the safety and efficacy of this brain-machine interface. Neuralink must continue to refine its technology, reducing any risks associated with implantation and long-term use. There's also the scientific challenge of fully understanding the complex symphony that is human brain activity. But overcoming these hurdles is only part of the journey. For Neuralink to truly revolutionize our world, it must navigate a labyrinth of social and regulatory issues. Widespread adoption depends on public acceptance and trust in this technology, a difficult feat given the profound ethical implications of interfacing with the human brain. Regulatory bodies, too, will need to grapple with the unprecedented nature of this technology, creating a framework that allows for innovation while protecting individuals and society. As we stand on the brink of a new era of human-machine interaction, Neuralink is not just a company, but a harbinger of the future, a future that is as exciting as it is unknown.